an important problem from complex number, and the problem is if x be a non-zero real number, prove that x to the power I, this is equal to e to the power minus 2n pi into cos of log x plus I sin log x if x greater than 0, and if x less than 0, the value of x to the power I is given by e to the power minus 2n plus 1 into 2n plus 1 into pi into cos of log minus x plus I sin log minus x. Right. Here we use an important result of complex number, which is the general value of logarithmic of z, and it is written as capital log z, which is given by log of mod z plus I into 2n pi plus argument of z or amplitude of z. And also we use the result a to the power I, this is equal to e to the power b into log a. This is the definition of exponential function. We generally use this result in every problem. Now we first write x as a complex number. Since it is given that x is a real number, we first let x greater than 0. Then we can write x, this is equal to x into 1. And 1 can be written as x into cos 0 plus I sin 0. Right. So we get mod x, this is equal to x, and argument of x, this is equal to 0. So if we want to write general value of log x, this is given by log of mod x plus I into 2n pi plus argument of x. We use this result. Okay, and now putting the value of mod x and argument of x, we get this is log of x plus I into 2n pi plus 0. This is log x plus 2n pi I. Right. Now we have to find the value of x to the power I. X to the power I, we can use this result as e to the power I into log of x. Here we put the value of log of x. We write the result as e to the power I into the value of log of x is log of x plus 2n pi I, and this is given by e to the power minus 2n pi, because I into I, this is I square, so it is minus 1 plus I into log x. Okay, so e to the power minus 2n pi into e to the power I into log x, and this is e to the power minus 2n pi into cos of, this is log x plus I sin of, this is also log x. Here we use the complex number in the form of e to the power I theta, this is equal to cos theta plus I sin theta. This is the Euler form of complex number we also use here. This is another result we use in this problem, and this is the first proof if x greater than 0 here. Okay. Now if x less than 0, then it is clear that x equal to, it can be written as minus x into minus 1. Okay. Why we write x, this is minus x into minus 1? Because here mod x, this is equal to minus x, because modulus of any number is positive, and since x is negative, so we give here another minus, so minus x is positive, and now we write minus x into, this is cos pi plus I sin pi. Okay, so we write mod x equal to this, and argument of x, this is equal to pi here, and putting the same value, we get the result of x to the power I. X to the power I, this is given by e to the power I into log x, and what is the value of log x? This is e to the power I into, we write this is log of mod x plus I into 2n pi plus argument of x, right? So e to the power I into log of minus x, because we already write here mod x equal to minus x, and argument of x, this is equal to 5, so I into 2n plus 1 into pi. Okay, and from here we get e to the power minus 2n plus 1 into pi into e to the power minus, sorry, this is not minus, this is plus I into log of minus x, and this term can be written as, this is equal to e to the power minus 2n plus 1 into pi, this is cos of log of minus x plus I sin log of minus x, right? And in this case x less than 0, and clearly this is the second proof and this is the first proof when x greater than 0, right? Very interesting problem, and we use 3 popular property of complex number. Very interesting and important problem of complex number. Thank you for watching.